Dividing polynomials has one simple rule we need to remember. Place each term in the numerator over the common denominator and then reduce each individual term that you've created. So for example 1, we would take 12x to the power of 4 and place it over the denominator of x. Then we would say plus 3x to the power of 2, x squared over the power of the denominator of x. So we've really separated it out into two fractions. Now we can reduce each of these fractions individually. Remember, when we have exponents divided by exponents, we subtract, and we leave the exponent that's left in the part of the fraction that had the greater exponent. So we have in the numerator left 12x to the power of 3, because we subtracted x to the power of 1, and there's nothing in the denominator, there's just a 1, so I don't have to write it. Then I say plus, and I'm going to simplify 3x squared over x. Once again, I'm going to subtract x squared minus x to the power of 1. I'll end up with just x. It's in the numerator, so I've got 3x in my numerator. It's simplified down to two whole numbers, or a simple binomial. Now let's look at the second one. We're going to write each term over the denominator of 5 and make 4 separate fractions. So I've got 20x cubed over 5 minus, and notice I'm pulling the signs out and separating the fractions with the signs, which is a really good idea. 30x squared over 5 plus 5x over 5 plus 5 over 5. If you have 4 terms in the numerator, you're going to have 4 separate fractions. So I can simplify these very easily. 20x cubed over 5, well, 20 divided by 5 is really 4x cubed. Nothing in the denominator, or just 1, so I don't write it. Minus 30x squared divided by 5, which would be 6x squared, plus 5x divided by 5. Well, that's just 1x, or x, plus 5 divided by 5, which is just the number 1. These terms are not like terms, so I just have a 4-term polynomial left. Example 3, negative 9x to the power of 4 over 6x to the power of 5 plus 18x to the power of 5 over 6x to the power of 5. Simplify the first term. I can reduce. It's going to stay negative, but I can divide both of these numbers, the coefficients, by 3. So I end up with the fraction 3 over 2. Then when I divide my exponents, I say x to the 5th minus x to the 4th gives me x. It needs to stay in the denominator because that's where my greatest exponent was. Plus the second term, 18 divided by 6 gives me the whole number 3, and x to the 5th over x to the 5th cancels, makes just 1, so I just have the whole number 3. The answer is negative 3 over 2x plus 3. Example 4, negative 12a cubed over 3a plus 36a over 3a minus 15 over 3a. Simplify the first term. It's still going to be negative. There's only one negative, but I say 12 divided by 3 gives me 4. A to the third divided by a to the 1. I subtract, and with a squared, it stays in the numerator. Just a 1 in the denominator. I don't have to write that. Plus 36 divided by 3 is 12, and a over a will cancel. Minus 15 divided by 3 would give me the whole number 5. I have nothing to do with that a, but it has to stay down there in the denominator, so I still have a fraction at the end, negative minus a over 5 over a.